Okay, let's take a look at this related rates question. So, alright, the question says, a particle moves along the curve y equals the square root of 1 plus x cubed. So I've graphed a picture of that curve you can see here in trusty foo plot. So here's the curve, square root of 1 plus x cubed. You can see that it looks like that. So a particle is moving along this curve. As it reaches the point 2, 3, the y-coordinate is increasing at a rate of 4 centimeters per second. So what's that going to look like on our picture? So imagine some little ball, is moving along this line. We don't know exactly how it's moving. It's moving with time, right? You're supposed to imagine that it's moving as a function of time along this curve. And we don't know exactly how it moves, but we do know one important thing, which is the rate at which its y-coordinate is changing as the little particle approaches 2 on the x-axis. So that's what it's saying. So as the particle reaches 2, 3, the y-coordinate is increasing as a function of time, remember, at a rate of 4 centimeters per second. And the question is, how fast is the x-coordinate of the point changing at the same time? Okay. So let's do that thing where we write down the things that we know and the things that we want to know. We already have the diagram, which is just the graph of the function. Alright, so we know, what do we know? Maybe I can get a little finer point here. We know that the way, oh god, that's terrible. Erase it. We know that dy dt. Okay, and what the hell does this thing mean? So by this I mean the rate at which the y-coordinate of the point is changing as a function of time is equal to 4, and the units are centimeters per second, when x equals 2. Okay? Alright, so that's the rate we know. In these related rates questions, you always want to relate two rates, right? So we want to relate the rate we know to the rate we don't know. So what is the rate that's being sought here? So the rate that's being sought is dx dt. So this is a function, right? But we don't need to know the whole function. All we care about is the value of that function when x is equal to 2. Oh wait, that's not exactly true, right? Yeah, okay. So it is going to be the case when x is equal to 2, but this when thing is a little bit misleading because it's talking about time, right? But don't worry, that's not going to matter, okay? We're just going to plug in x equals 2. Alright, so let's get down to the nitty-gritty. What comes next? The equation that relates everything. So what could that possibly be? It's just the equation that we're given here. This dumb curve that somebody just made up is y equals the square root of 1 plus x cubed. Okay, so in this case we're just kind of given the equation that relates the variables. Sometimes we have to think about what it should be, but this time they just tell us. So what do you do now once you get this thing? So when you get the equation, you take d dt of both sides. So I think one thing that makes these problems a little troubling for some people is that they find the difference between taking the derivative with respect to x and taking the derivative with respect to t confusing. So we're taking the derivative with respect to t, okay? Normally we take the derivative with respect to x, and in that case the derivative of x is 1, but in this case the derivative of x is going to be x prime. I'm going to call it dx dt because we're taking the derivative with respect to t. So what you should imagine is that x is some secret function of time that we just don't know, and y is some secret function of time that we just don't know. It involves the letter t somehow. And so what we're doing is we're taking the derivative of this, both sides of this equation, and we're doing something to these secret functions, but we're doing it using implicit differentiation, and so we never actually have to worry about that part. So I hope that's not too confusing, but so this is what happens. So the derivative of y with respect to t, we're just going to call dy dt. right? And we've got some chain rule action going on this other side here. The 1/2 comes down. You know the radical is a 1/2. And I get 1 plus x cubed to the minus 1/2. Okay, and now, you know, the chain rule says that I owe the derivative of the inside. So for the time being, let me just kind of literally say that. The derivative of the inside is d dt of 1 plus x cubed. Okay, so maybe that'll make the problem a little easier if we do that in 2 steps. Alright, so let's keep going. We need to know what the derivative of 1 plus x cubed is with respect to t. So I'll recopy this part. This is 1/2 1 plus x cubed to the minus 1/2. And now the derivative of a number is always 0, right? And when you take the derivative of this part, 3 comes down and becomes a square. And now by the chain rule, I owe dx dt, and that's because we're taking the derivative with respect to t instead of x. And that's where the buck stops. So what's on the left here is dy dt. Okay, and look, we've related the rates. So here's one rate, this is the rate we know, and here's the rate we want to know, okay? So now we can use this extra information we have. We're interested in what happens when x is 2, y is 3, and we know we can assume that, that dy dt is 4. So if we plug in all those values, we get something where everything is known except for dx dt, and that's exactly what we want to know. So let's plug in x equals 2, and we plug in y equals 3 if y showed up anywhere, but it doesn't. And we know that dy dt is equal to 4. Just going to double check on that. Come on, dumb thing. Okay, yeah, that's right. So what happens when we do all that? We get this equation. 4 is equal to 1/2. Now I plug 2 in here. 2 cubed is 8, and so I've got 9, which is good because, you know, 9 works well with 1/2 power. And this 3 hangs around, and this becomes a 4 when I plug 2 in for x. And this is the thing that we don't know, dx dt. Alright, so now I just have to solve for this. Okay, solve for dx dt. Alright, so that's easy, right? That's you can go to sleep now because you should know how to do that. So what can you do? You can multiply both sides by, let's just sort this stuff out on the left. So this is 1 over the square root, right? So this is 1 over 2 times the square root of 9 is 3. And I've got this stuff to worry about. 3 times 4 is 12, so that can go up here. And here I've got dx dt. And what is this? This is 12 over 6. So all that stuff is really just equal to 2 dx dt. And on the other side here is 4. And if it's okay with you, I'm going to finish up right here. So now just divide both sides of this equation by 2, and you get 2 is equal to dx dt. And you're done. Okay. What does it mean? So what it means, if you go back to this picture, it means that under these assumptions, if the particle is moving along this line in such a way that when it approaches 2, 3, it's moving in the y direction at a rate of 4 centimeters per second, it's going to be moving in the x direction at 2 centimeters. The units here are centimeters per second. Alright, excellent. Nice job.